Hello, my name's Jeff Messier. I'm a professor in electrical and software engineering in the Schulich School of Engineering at the University of Calgary. And this is a presentation that I'm going to make at the 2023 Data That Makes a Difference conference. It's a conference in Calgary that focuses on how data can be used to improve the services and policies for people who are experiencing homelessness. And the title of my talk is Visualizing Journeys Through the Homelessness and Housing System of Care. So I'd like to acknowledge that I'm grateful to be able to make my home in southern Alberta. That's where I'm currently recording this presentation. And this is in the Treaty 7 region in southern Alberta, which includes the Blackfoot Confederacy, the Siksika people, the Piikani people, the Kainai people, as well as the Tsuut'ina First Nation and the Stoney Nakoda First Nation, which includes the Chiniki Bearspaw and Goodstoney First Nations. And this land is also home to the Métis Nation of Alberta, Region 3. And I've been fortunate enough to live my entire life in Western Canada. I grew up in Treaty 4 country in the near the Cypress Hills in Saskatchewan, and was fortunate to go to school with kids from the Niconeat First Nation. And it's really, this is, I feel very lucky to have lived my life here. This is a beautiful part of the world. I'm also very lucky to acknowledge the support of a bunch of really great agencies that have made this work possible. In particular, the Calgary Homeless Foundation is a big partner for this particular presentation, as you'll see. Okay, so first of all, often I have to kind of explain myself a little bit, like what's an engineer doing in in working in the homelessness sector. And the way that I sort of always explain this is that engineers fundamentally build things for people to use. And I want to build things that will improve the services provided to people who experience homelessness. And so, the research question that I strive to answer, that my research group strives to answer, is basically what type of software tool allows housing and homelessness staff to make the best possible use of their data. And this research has a bunch of different elements or facets to it. So we do look at certain types of machine learning to try and solve this research question. We explore cooperative and user experience design methodologies. But the third area is data visualization, and that's going to be the focus of this presentation. So there can be no doubt that the most important component of the homelessness system of care, medical system of care, is the staff working within that system. It's the people that are working within the system to provide the services and to provide the care. And it's helping those people that really is the focus of our work. And staff at all levels of the system of care use data for decision making. This data is very well established in the homelessness system of care. And it's used, as I said, by staff at all levels. So frontline staff working with individual people, trying to connect them to services, will be pulling data maybe on that person's experiences, on different programs that are available for that person. So they're diving into data sort of at the individual level. Whereas people in more of a management or a leadership role might be looking at more aggregated data to sort of understand how a program or an agency or a system of programs or a system of agencies might be performing and behaving. And depending on the interface to this data, the cognitive load of accessing the data and understanding it can be considerable. So often, if you're working with a very text-based database type system, or a lot of spreadsheets perhaps, you're constantly looking at tables and tables of data. Maybe you've got a couple of windows open, accessing a couple of different sources of data, and just kind of mentally aggregating that and going to all these multiple sources is taxing. So how can we make this easier? Well, there's a bunch of different ways, but the way that I'm going to talk about in this particular talk is the use of pictures. And so this area, or this talk, sort of falls under the broad area of human-computer interaction, or HCI. And if you look at the definition of HCI on the University of Calgary Computer Science website, part of that definition says that HCI involves how groups and individuals interact with visual information. And that's really what this talk is all about. And HCI is a rich and exciting place, and it's got a whole bunch of different tools and ideas for visualizing data. And the nice thing about HCI and data visualization is that, it's kind of the old, picture is worth 1,000 words. So a really well-designed visualization can quickly, efficiently, and effectively take a whole bunch of data from a whole bunch of different sources and summarize it in a very useful way. However, this is only true if the visualization is very carefully designed. And part of what I want to talk about in this presentation is kind of the things that you need to think about when you're putting a visualization together. So my goal for this talk is to present some ideas for visualization in the homelessness sector, and but hopefully get you excited about visualization. And if you're a person who works in the sector, get you excited and get you thinking about how this visualization might work for you. And so I want to cover off some of the basics of how to construct a visualization, and more importantly, how to critique a visualization. So to start off our discussion of visualization, here is a visualization that seeks to represent different breeds of dogs. And part of this visualization is a rating of different breeds of dogs. So dogs have been rated based on intelligence, how much they cost, longevity, and so on. And as you move left to right in this visualization, you have the rank of the dogs increases. So the more highly ranked dogs appear towards the right of the visualization. And on the vertical axis, we have popularity. So the higher up you are on the diagram, the more popular the breed is. And this visualization has divided itself into 4 quadrants. So if you're in the upper right, you're both highly rated and popular. If you're in the lower left, you're low rated dogs and unpopular. Upper left is low rated dogs and highly popular, and so on. And so kind of maybe a provocative figure, perhaps, if you're a dog owner or a fan of a particular breed. I happen to own a Welsh Springer Spaniel, which is down here in the lower right, Overlooked Treasures, highly rated, but not as popular. And yeah, so I mean, this is an interesting visualization, but if we're going to talk about visualization design, I think it's important that we are able to sort of objectively critique visualizations. And so if we take a look at that visualization, the first critique I would say is there's too many dogs, right? There's a lot of different dogs on that visualization, and there's been studies to show that most people can handle 7 plus or minus 2 cognitive features or things that you can think about simultaneously. So people can kind of simultaneously think about approximately 7 different factors. And so that's not a bad rule of thumb for how many sort of big sort of things you can have on your visualization. And so to improve the data or the visualization in that respect, you could perhaps consolidate some of the breeds. You could just show spaniels rather than all the different kinds of spaniels, for example. But, that has to be balanced with the utility of the figure. So if you're looking for a particular breed, you might want that level of detail. The second critique is, how could somebody possibly just rate a dog? How can you sum up everything that a dog is with a single number. And this speaks to the data behind the visualization. So the value of a visualization rests a lot on, how the limitations of the data used to generate the figure, as well as any pre-processing that may have, affected how the visualization looks. And anytime, a multifaceted thing is summarized with a numerical score, you've really sort of reduced the dimensions of something. There's risk there. The last point is related to bias. So my dog happens to appear very favorably in this particular visualization. And so I like it for that reason. If I was a bulldog owner, I would probably be a lot less of a fan of that particular visualization. And so this speaks to bias, both confirmation bias, am I just looking for a visualization that confirms the ideas that I already have, as well as perhaps hidden biases that can exist in the data, kind of just fundamentally as part of the data. So for example, has the data preferentially sort of been recorded for a particular group of people, but has it neglected another group of people? And so these are some critiques and themes that I want to sort of bring forward as we look more specifically about more specifically at visualizations using housing and homelessness data. So I basically have two design criteria for the visualizations in this presentation. First of all, they need to be feasible. So everything that I'm gonna show you can be implemented on standard data dashboard platforms. So these are platforms like Tableau, Power BI, Click. These types of platforms are very versatile. They can import and connect to a whole bunch of different data sources, from files to spreadsheets to database cloud systems. So they're very versatile. They're quite easy to design, or relatively easy to design with. So they're not meant to, you don't have to be a programmer to use them. They're meant to be fairly accessible from a design point of view. And they're relatively affordable for agencies. So if you are a service provider watching this video, one of these platforms, Tableau, Power BI, or Click, can replicate basically everything I'm going to show you and can do it in a pretty practical and affordable way. The second design criteria is that I'm going to try as much as I can to take into account the user perspective when I'm designing my visualizations. This is what's known as this sort of is a little bit related to the area of user experience design, where you put the experience of the user front and center when you're designing something for them. And it's really important that we have that user perspective, because even though a picture is worth a thousand words, when it comes to pictures, one size definitely does not fit all. And so I'm going to look at two different user perspectives. The first different user perspective is what I'm going to call the system level perspective. And example users that are interested in the system level perspective might be managers or people in leadership positions at particular homelessness agencies or managing particular programs. Government policy staff and researchers take this kind of system level perspective, as well as just system planners, people that are looking at how a bunch of programs and agencies work together. And so the kinds of questions people in this user group would ask was, for example, what are all the services that make up a particular system of care? How do all these services work together? How do people flow through the system? What are the common paths that people take through the system? If you're the manager for a particular agency or program, you might be wondering how your particular agency fits into and interacts with this broader kind of care ecosystem. And, again, if you're looking at this from the perspective of a particular program or agency, you might be wondering about where do the people that you're serving come from, and where do they go, and where are they going after they finish with your agency or program. The second user perspective is the individual person perspective. Example users that are interested in this perspective are the people who work directly with individuals. So social workers, frontline agency staff, housing case managers, anybody in a case management role where you're talking and have a relationship directly with just one person, and you're trying to understand that person better and connect them with appropriate supports. And so questions that this user group might be interested in are things like, what has the person I'm helping already experienced? What was the journey leading up to the point where, we're talking together now? Are there other people in the system of care that have had similar experiences to the person that I'm trying to help right now? And can I learn anything from their experiences? So we're not just sort of redoing the same thing over and over again. And are there any signs that the person I'm working with might need extra supports? Are there maybe some warning signs that we should perhaps be paying attention to? Now, the data that I'm going to use to create these visualizations is an anonymized data set provided by the Calgary Homeless Foundation through our ethics-approved university research relationship that we have with the Calgary Homeless Foundation. And the CHF, or Calgary Homeless Foundation, has provided us with what they refer to as their participant journey data, which shows how the same individual in Calgary, moving through most of the housing and homelessness agencies within Calgary, how long each individual interacts with each or a variety of different services and agencies within the city. So the time window that we're working with is January 1st, 2008 to January 1st, 2023. There are about 87,000 individual profiles in this time period and 144 different services and programs. And this is a big group of people accessing a fairly large number of services. So there are a whole bunch of different combinations of ways that that many people can access that many services. And there are about 3,000, slightly more than 3,000 different combinations that people access services, individual services or combinations of two, sometimes three, or maybe four services at once. And so if we think back to our dog visualization, this means that we have over 3,000 different things that we want to look at, right? Over 3,000 breeds of dog, if you like. And we're going to have to simplify this if we want to represent this as a picture. And so a lot of what we're going to be talking about is consolidating a lot of these combinations into broad categories, just so that we can sort of cognitively handle them and represent them reasonably in a picture. And the appropriate type of categorization that we use depends on our user perspective, as we're going to see. Now, the first group of visualizations that I want to present tackle this system level view, so this high level system perspective. And people within a system of care move between services, and we can think of this as sort of a flow of people between services. And in the area of human-computer interaction, something called network diagrams are a popular way to visualize system flow. And this is an example of a very simple network diagram. We have three circles that are referred to as nodes. And a node represents a service. So a particular shelter, a particular housing program would be represented by one of these dots. And I'm going to vary the size of the dots depending on how many people use that particular service. So the big dots are used a lot, the smaller dots are used less. Now, if people flow from one service to the next, or people move from one service to the next, this is represented by an arrow. And these are referred to sometimes as edges in the area of graph theory, nodes and edges. And each arrow or edge represents flow between services. And I'm going to adjust the thickness of the arrows to represent how frequently a particular transition is made. So if a lot of people are moving from one agency to the next, the arrow representing that transition is going to be bigger. So here's an example of a network diagram that represents flow through the Calgary Homelessness System of Care between the 1st of July 2018 and the 31st of December 2021. So about a 3.5-year period. To make the diagram sort of understandable, I guess, I've taken those 144 different programs and I've very considerably categorized them. All the shelters in Calgary are summarized by this large node. All of the housing programs are summarized by this large node. And in addition to the shelter and housing nodes, we have an entry node that represents when the transition somebody takes when they first appear in the data. We have an exit node that allows us to see the transition that people make when they leave the data. We have an other node that represents not necessarily a shelter or housing program, but something like a diversion program or a referral program. So not a place where people are, but something where they might perhaps be on a bit of a list. And another thing we have here is a gap node. And the gap node represents, as the name suggests, gaps in people's records. So sometimes people will just disappear for a period of time. And if that period of time is greater than 30 days, we record it as a gap in their system use, and they make a transition from the whatever node they're in to the gap node. And I don't, in this case, show the average number of people per day that are in a gap, because we don't really know where they are when they disappear from the data. And so, there's lots going on in this data, even with the very sort of coarse level of categorization that I've used here. This is a very busy diagram. And the purpose of my presentation is not to dive into all the details and to get you to understand and appreciate every single arrow represented on this diagram. It's mainly just to present this as an idea, as a way of visualizing system flow. And hopefully you can get a bit excited about this if you're a system provider, and you can think about how a visualization like this could perhaps be constructed for your own organization and your own data. Something I should mention is that we have a lot of light gray arrows here. If a transition has fewer than one person per day on average making it, I just show this as a light gray arrow, and I don't bother showing how many people per day make the transition. And so one of the things that I want to talk about is the way that I pre-process the data influenced how this diagram looks. So this is a visualization created using a 3.5-year window. And basically the way that I constructed the visualization is on July 1st, 2018, I basically sort of took a cut of the data, and then everybody who was already in the system on July 1, I showed them as appearing in one of these system nodes. So if you happen to be in shelter on July 1st, 2018, you would show up in this entry arrow to shelter, even though that wasn't the day you entered shelter. So it's a little bit misleading in that way. By a similar token, on the last day of the data window, December 31st, 2021, I stopped the analysis, and then everybody who was in shelter is recorded as leaving the data set on that day. And even if they were still in shelter after that point. Now, I experimented with a few other ways of creating the cohort, taking removing people from the system that were truncated like that at the start and entrance of the windows. It turns out that this actually doesn't cause a huge amount of error in the figure, but it is an example of the kinds of things that you need to think about when you're processing the data to construct the visualization. Now, going back to our original diagram, I suppose this is in some ways an interesting diagram, but it's also of very limited use. This might be informative for people understanding the system of care at a high level, but if you're working within the system of care, there's not a lot you can do with the information presented in this diagram. So let's say now you are you're managing a shelter. You're the CEO of a particular shelter in Calgary, and you want to understand how your shelter interacts with the broader system of care. If that's the case, this kind of diagram might be of more interest to you. So this is exactly the same diagram as before, except I have separated out a single shelter, one of the mid-sized shelters from Calgary. And if you're the person running this shelter, or the management team, the leadership team running this shelter, this diagram illustrates how your shelter interacts with the rest of the system of care. So for example, you can see that, if you're looking at how people arrive at your shelter, you have 6.5 people per day arriving directly at your shelter, as compared to 10.7 people per day arriving at the other shelters. So you're taking almost half of the traffic in your particular shelter, which is quite a lot. This particular shelter also has quite a few gaps in the data records for people using their services. So 10 people on average per day are transitioning to the gap node. About the same number are transitioning back, as compared to only 9 people from the other shelters and 8 people from the other shelters. And so this particular shelter just happens to have a lot of people with very sort of sporadic, episodic shelter use. So maybe that says something about the type of people using your facility and might inform how you would decide to serve those people and the types of programs you might be interested in. If you're interested in how people transition from your shelter to supportive housing, there are a bunch of different paths here. People transition directly from your shelter to housing. People also transition to this intermediate node, which is using shelter and housing at the same time. And this seems like maybe it's double dipping programs, and it might be, but it's also probably the reality that when somebody is referred to a housing program, even though you're on record as being admitted to the housing program, maybe your spot isn't quite ready and you have to spend a few more days in shelter. Okay, now I want to change my perspective and go from looking at overall system flow to looking at just one person. And so this is the individual person perspective that's more of interest perhaps to frontline case managers who work directly with individual people. Now, in my previous example, in my previous flow examples, I used a lot of categorization, right? So I lumped all shelters into one category. I lumped all housing programs into one category. This is not a good idea when you're trying to understand an individual person. So when dealing with an individual person, it actually does matter which housing program a person has been accessing or which shelter they've been accessing, because there's different supports and different characteristics for each program. And so if we try to use the flow, sort of the flow type network diagram to represent an individual, we get something that looks like this. So this is just one person. But now rather than lumping all shelters into one category and all housing programs into one category, I'm representing all of the individual shelters and housing programs this particular person has accessed. So we have accessed 1, 2, 3 different shelters, 1 referral program, and 1, 2, 3 different housing programs, and a bunch of simultaneous combinations. So here's 2 housing programs that probably represent one person or a transition between one housing program to the next. Here's a time where this person was on the referral program and transitioning to this housing program. And so we can sort of take away 2 things from looking at this picture. One, maybe it looks kind of pretty, but it's also pretty useless. So it's very busy. There's a lot going on here. And more importantly, we don't know when these events have happened. We do know from the entry and exit nodes that transitioning to shelter 1 was the first thing that happened to the person, and transitioning out of shelter 3 was the last thing that happened to the person. But we have no idea when the transition to shelter 2 occurred, if it occurred before or after the transition to housing 2, and so on. And so time is really, really important. And so the length of time spent is also really, really important. And so it's not just that somebody was in shelter. It matters how long they were in shelter. 2 days in shelter is much, much different than 2 months or even 2 years in shelter. So we need to represent that time component. And this is where timeline diagrams are a lot more useful. So this is that exact same person represented using a timeline diagram instead of a network flow diagram. Now I've cheated a little bit here. Like I'm now back to using the shelter housing and program categories. This shelter category contains 3 different shelters. The housing program contains 3 different housing programs. But the main point I wanted to make with showing this timeline diagram is it now, as the name suggests, has a time component to it, which is really, really important when working with an individual person. So for example, we can see here that the very first interaction this person has with the system of care is a series of relatively sporadic interactions over 2 years with shelter. So the person is kind of in and out of shelter. There are big gaps between these episodes of shelter use. Then we have a very large gap of more than a year and a transition to a continuous period of using a housing program, back to shelter, to a referral program, back to shelter and housing. And so now we can see how long the person has been in a particular place, which is really a lot more informative when trying to understand what the person has been through and connect them with more appropriate supports. So the last thing I'd like to talk about is how visualization can be combined with some underlying data analysis. And in this particular example, I'm going to demonstrate how the analysis and visualization combined allows us to learn from the experience of groups of people in the data. So still for this example, we're going to be focusing on a particular individual, the same individual that we looked at in the previous visualization. But now we're going to try to understand that person's experience a little bit better by looking for other people in the data that have had a similar experience. And this will allow us to answer a couple of questions. So first of all, how many people in our data set have had a similar experience to the current person we're working with? And the second question is, if we can gather a group of people together who have had similar experiences, can we use those experiences of the group to kind of anticipate what to expect when working with, our current person? And the data analysis that I'm going to use is a variation on something called nearest neighbor sequence estimation. And so this comes from the family of algorithms that, music streaming services or video streaming services might use to anticipate viewing patterns. So basically, you look at a person's, history of listening to songs. You find other people who have similar listening histories, and then based on that group of similar people, you recommend other songs that the person might like. This is a very, very similar idea. And so what I do for this data analysis is I create something I'm going to call a similarity cohort. This could also be known as a neighbor set. Basically, I want to find a group of people in the data that are similar to the current person that I'm working with. And there's a whole bunch of different ways you can do this. The way that I've chosen to do it is basically for a particular point in time in the person's timeline that we're working with, I look at everybody else in the data who was using the same service as our person at that same time point in their service histories. So if we're 61 days in to the timeline of our current person, I look to see who else in the data set was using the same services as our current person after 61 days in their journey through the system of care. Once I find the group of people that were using the same service as our person at the same time in their system journeys, then I further reduce the set by looking at the histories of those people leading up to the time point. And I keep only those people that have histories that are at least 75% the same as the person that we're working with. And I determine this 75% just by looking at the total number of days everybody spends accessing different services. So that thins out the cohort a little bit. And then once I've determined the similarity cohort, I go one step further and I look 30 days into the future and see what our similarity cohort was doing or what services they were accessing 30 days into the future. And this allows us to anticipate what we might expect from the person that we're currently working with. Okay, and here's what our visualization looks like. So we have exactly the same timeline diagram at the top here, but we've got two more plots. The middle plot shows how many people we have in our similarity cohort at a particular point in time along our person's timeline. And this bottom plot shows what services the cohort are accessing 30 days into the future. And so what we can see here is that if we look early on in our person's timeline, when we've got sporadic on and off again sort of shelter access, lots of people have sporadic shelter access early in their service or early in their journeys as well. So we have over 20,000 people who have the same sort of sporadic early kind of shelter access. If we look at what those people are experiencing 30 days into the future, most of them are experiencing a gap in service. And again, this sort of agrees with the sporadic nature of the shelter access patterns. Now, after we go through our sporadic shelter access, we have a big gap in our system of care access. And we can see that the number of people in our similarity cohort starts to drop as the gap grows. So fewer and fewer people in the data have such a long gap as our gap begins. And something also interesting happens here where when we access housing. So it is relatively rare in the data to have sporadic shelter access, a massively long gap, and then to appear directly in a housing program. And as a result, you can see the size of our similarity cohort drops. It looks like it almost drops to zero, but it's not quite zero. So if we zoom in on this particular timeline, the size of the similarity cohort drops to about 100 people. So it's a big drop. We were up at 18,000 here before we entered housing. But, we still have 100 people in the data that resemble the person that we're working with. And of those people, a very large proportion of them stay in housing. So we see the proportion of people who are experiencing a gap drop way down. And now we're in with a similarity cohort who tend to stay in housing. So our proportion of people in housing jumps way up. This, however, reverses itself once we leave housing. So once we leave housing and we experience a gap, and my time points are a little sparse here. So I've got a point here, and then the next point in time that we calculate our similarity cohort isn't until after we leave housing. So at this point, we have a history of housing, but now we've experienced a gap. And then now our similarity cohort jumps right up again. So there's quite a few people who experience a gap after housing. And the proportion of people who are experiencing a gap after housing tend to continue to experience a gap. So we can zoom back out again and take a look at one more sort of region of interest here. So at this point, starting in February 2015, we have a period of time where there's some fairly steady but somewhat sporadic shelter access, a bit of a stint in housing, some work with a referral program. And if we just sort of zoom in on this region, we can see that our similarity cohort, it's not tiny, but it's sort of bumping around kind of the 500-600 person number. So still a reasonable number. But the outcomes for our similarity cohorts jump around a fair bit. So the proportion of people in our cohorts that experience shelter in 30 days or a gap in 30 days or even housing in 30 days tends to jump around a fair bit. Now, what conclusion would a person take from this portion of the visualization? Perhaps no conclusion at all. Remember, these visualizations should never be used in isolation. A visualization like this should only ever be used in conjunction with actually talking to the person that's being shown in the data. So a caseworker wouldn't just be looking at this screen, they would be actively communicating with the person represented in the data. And hopefully through that direct personal interaction, they would learn more about the person's context that would help kind of make sense of what this visualization is showing. But anyway, beyond this particular example, hopefully what you can see or what you take away from this particular visualization is how a person's timeline can be combined with a bit of data analytics to perhaps provide a little bit more context or a little bit more insight into what the person is experiencing. So to conclude, we've seen a lot in this presentation. I've shown a lot of information, a lot of different kind of visualizations, and I want to sort of step way back from all that stuff and just make three relatively short points. I hope after watching this visualization, you can see, first of all, that a properly designed visualization makes accessing data a lot easier, and particularly for staff people that are doing often a very difficult job under very difficult conditions. Anything we can do to make work life easier, to make accessing data more efficient, is a win. And truly, a well-designed picture, a well-designed visualization, if we properly understand the limitations of the underlying data, and if it's properly customized to show the person who's using it what they need to see, can be a really, really important tool. The second point I wanted to leave you with is that these visualizations are accessible and affordable. Everything that I showed you in this presentation can be implemented with standard data dashboard platforms like Tableau, Power BI, Click, that are very flexible in terms of the types of data that they can connect with. So it doesn't really matter if the data in your organization is just in a bunch of files, if it's in a database, if it's in some kind of cloud storage. Most dashboard platforms are pretty flexible into what sort of data they can pull in. And finally, kind of a bit of a cautionary point. Visualizations must be designed with care. So we've raised a few issues on and off throughout this presentation, showing that there's a lot that goes into the design of a visualization, and unless we take the end user into account, unless we're very sort of aware of the limitations in the data, potential biases in the data, a visualization could do harm instead of good. And so we must, sort of take that into account when we're doing this design. And finally, I'm very happy to connect with you on this. So this is a link to my website. It's got a little bit more information about the work that I'm doing. And if you're working in this space and you're interested in, implementing this, visualization, or really any form of data analytics or data science work for the housing and homelessness sector, please reach out to me and I'd love to chat with you.